Bismillahirrahmanirrahim. In the last lecture, we discussed about the physiological anatomy of the brain. Now we discuss about the physiological anatomy of the spinal cord. A spinal cord is a cylindrical structure present in the central canal of the vertebral column, present in the central canal of the vertebral column. Superiorly, it becomes continuous with medulla oblongata at foramen magnum. So superiorly, it becomes continuous with the medulla oblongata at foramen magnum. Inferiorly, it ends in adults at the lower border of the first lumbar vertebra. So inferiorly, spinal cord ends in adults at the lower border of the first lumbar vertebra. In children, it ends at the upper border of the third lumbar vertebra. In children, it ends inferiorly at the upper border of the third lumbar vertebra. Why the difference of ending of the spinal cord in adults and the children? The reason is, in growing children, rate of growth of spinal cord is not as rapid as the rate of growth of the vertebral cord. So in growing children, the rate of growth of the spinal cord is not as rapid as the growth of the vertebral cord. So that's why in adults it ends at the level of the lower border of the first lumbar vertebra instead of the upper border of the third lumbar vertebra in children. Spinal cord is surrounded by three meninges: the biomatter, arachnoid matter, and the neural matter. And these meninges become continuous with the meninges surrounding the brain. In the subarachnoid space, there is also cerebrospinal fluid present, which provides protection to the spinal cord. I mentioned that spinal cord is cylindrical structure, but there are enlargements. There are fusiform shape enlargements in the cervical and lower thoracic and lumbar regions. In the cervical and lower thoracic and lumbar regions, these are called cervical and lumbar enlargements. These are called cervical and lumbar enlargements. Just before the lumbar enlargements, just below the lumbar enlargements, the spinal cord tapers. And this is called the conus medullaris. The spinal cord tapers, and this is called conus medullaris, which terminate into a fibrous thread-like structure, the phylum terminale. So just below the lumbar enlargement, the spinal cord tapers, right? And this part is called conus medullaris. And that is connected to a fibrous thread-like structure, the phylum terminale, which is attached to the back of the coccyx. This phylum terminale is attached to the back of the coccyx. back of the coccyx. On the anterior surface of the spinal cord, there is anterior median fissure. This is the anterior median fissure. And on the posterior surface, there is a posterior median sulcus. So this is the anterior median fissure, this is the posterior median sulcus on the posterior surface. From the surface of the spinal cord arise 31 pairs of the spinal nerves. So 31 pairs of spinal nerves arise from the surface of the spinal cord. Among these 31 pairs, 8 are cervical, 12 thoracic, 5 lumbar, 5 sacral, and 1 coccygeal. So among the 31 pairs of spinal nerves, 8 are cervical, 12 are thoracic, 5 are lumbar, 5 are sacral, 1 is coccygeal. Each spinal nerve arises from the spinal cord through two roots. Through two roots, the spinal nerve originates from the spinal cord. The ventral root, anterior root, which is motor, and dorsal root, posterior root, which is sensory. So motor root is the ventral root, and sensory root is the dorsal root or posterior root. In the dorsal root, there is also dorsal root ganglia. So in the dorsal root, there is also dorsal root ganglion present. Now these two roots of spinal nerves are attached to spinal cord through a number of rootlets. So multiple rootlets, these merge to form the dorsal root and the ventral root. Keep in mind that spinal nerves in thoracic and lumbar regions, are identified according to the number of vertebrae at the lower border of which the spinal nerves come out. So I told you that in the thoracic and lumbar region, the spinal nerves are numbered according to the number of the vertebra at the lower border of which spinal nerves come out. It means spinal nerve thoracic T1, it emerges out at the end of the first thoracic vertebra. Second thoracic nerve comes out at the lower border of the second thoracic vertebra. Similarly, first lumbar nerve, it comes out at the lower border of the first lumbar vertebra, and so on. But there are 8 cervical nerves, and there are 7 cervical vertebrae. 8 cervical nerves and 7 cervical vertebrae. So, first cervical nerve is at the upper border of first cervical vertebra. Second cervical nerve is at the upper border of second cervical vertebra. And keep in mind, 8th cervical nerve is between C7 and T1. 8th cervical nerve is between C7 and T1. So these are the way in which these spinal nerves are numbered. We have discussed that spinal cord ends in the adults at the lower border of the first lumbar vertebra. Right? Of course, below this level, there is lumbar nerves, sacral nerves. So, after the end of the spinal cord, at the lower border of first lumbar vertebra, the descending spinal nerves in the vertebral canal, these are the lumbar spinal nerves, sacrospinal nerves, these descend in the vertebral canal of the vertebral column to come out through the respective segments, lumbar and sacral segments of spinal cord. And this collection of the descending nerves, the lumbar nerves, sacral nerves, these were called cauda equina. Cauda equina, it means horse tail. It means horse tail, that is the cauda equina. And these are the descending lumbar and sacral nerves which descend in the vertebral canal to come out to the lumbar and sacral segments of the vertebral column. Each spinal nerve comes out from this vertebral column through the intervertebral foramen. Through the intervertebral foramen, the spinal nerve comes out. And then it divides into two rami. It divides into two rami, posterior ramus and the anterior ramus. Posterior ramus and the anterior ramus. Posterior ramus is smaller, and posterior rami, these pass posteriorly. Posterior rami, these pass posteriorly to supply the skin and muscles on the back of the body. So posterior rami of the spinal nerves pass posteriorly to supply the skin and muscles of the back. Anterior rami, keep in mind, anterior ramus is larger. So larger anterior rami, these pass anterolaterally, to supply the skin and muscles on the anterolateral aspects of the body, and also the limbs. So limbs and anterolateral aspects of the body are supplied by the anterior rami of the spinal nerves. So these anterior rami, these unite to form plexus, at the root of the limbs. So anterior rami are joined together to form plexus at the roots of the limbs. Say, at the root of the upper limb. At the root of the upper limb, anterior rami join to form the cervical and brachial plexus. At the root of the upper limb, the anterior rami join to form the cervical and brachial plexus. And anterior rami at the root of the lower limbs. The anterior rami or spinal nerves unite to form lumbar and sacral plexus. At the root of the lower limbs, there is formation of the lumbar and sacral plexus by joining of the anterior rami of the spinal nerves. So this is about the spinal nerves. You can see the section to the spinal cord, the transverse section, and you see on the periphery is white matter, in the center is gray matter. In the center is gray matter, on the periphery is white matter. In cut section, transverse section, you see H-shaped gray matter. H-shaped gray matter consisting of the two ventral horns and two dorsal horns, two ventral horns and two dorsal horns, joined by a transverse commission. Joined by a transverse commission. So gray matter will be two dorsal horns, two ventral horns, and a transverse commission. Transverse commission. So the spinal cord gray matter will be the ventral horns or anterior gray column, the dorsal horn or the posterior gray column, and then in the segments T1 to L2, in the segment T1 to L2, there is also lateral horn or intermedial lateral horn. So spinal cord gray matter is in the form of ventral horn or anterior gray column, dorsal horn or posterior gray column, and then in the segments T1 to L2, there is lateral horn or the intermedial lateral horn. Similarly, the white matter of the spinal cord, is in the form of anterior white column, posterior white column, and the lateral white column. So anterior white column is between the ventral root and the median sulcus. This is the anterior white column. Posterior white column is between the median sulcus and the entry of the dorsal root. This is the posterior white column, and you see the lateral white column between the dorsal ventral root and the dorsal root is the lateral white column. So three white columns in the spinal cord: anterior white column, posterior white column, and the lateral white column. Now these white columns contain the ascending and descending tracts. Ascending and descending tracts. So this was about the gray matter and the white matter of the spinal cord. The gray matter consists of the cell bodies of neurons, proximal portion of the processes, the dendrite and the axon, embedded neuroglide. The white matter consists of the nerve fibers embedded in neuroglide. White matter consists of the nerve fibers embedded in neuroglide. So this was about the structure of the spinal cord and then the arrangement of the spinal nerves. Right? So what is a dermatome? A dermatome is the area of skin supplied by one spinal nerve. So area of skin supplied by one spinal nerve is called a dermatome. There is actually a systematic distribution of the spinal nerves to the skin. So the systematic distribution of the spinal nerves to the skin, and the area of skin supplied by one spinal nerve is called dermatome. And around the body, these dermatomes are like horizontal bands. You see, around the body, these dermatomes are like horizontal bands starting from the anterior midline to the posterior median plane. So these are the dermatomes, just like horizontal bands around the body from anterior midline to the posterior plane of the body. You see again on the back of the body, these are the dermatomes. Keep in mind there is also overlapping of the adjacent dermatomes. There is also overlapping of the adjacent dermatomes. But the maps of these dermatomes are available. Maps of these dermatomes are available. Like this, these are the maps of dermatomes. So these maps help the clinician. These help the clinician to determine the level and the extent of lesion in the spinal cord. So these maps of dermatomes are available, and these help the clinicians to determine the level and the extent of damage, to the spinal cord. Let us say there is damage, this is a loss of motor supply, sensory supply to here. So it means it may involve the T2, T3. Right? So these maps of dermatome, these help clinicians to determine the level and the extent of damage to the spinal cord. This was about the dermatome. Right? I mentioned that the gray matter spinal cord is in 3 columns: anterior gray column, or the ventral horn, posterior gray column, or the dorsal horn, and then the lateral horn, or the intermediate lateral horn, or gray column. Now in these gray columns, neurons are present, nerve cells are present. I discussed about the nerve cells. Nerve cells are neurons in the gray matter of the spinal cord. First, about the neurons in the ventral horn or anterior gray column. So neurons in the ventral horn or in the anterior gray column. Now in the ventral horn, 2 types of neurons are present. So 2 types of neurons in the ventral horn. The first one is alpha motor neurons. Now, these neurons are large and multiple. So alpha motor neurons are large and multipolar. Their nerve fibers come out to the ventral root of spinal nerve. Their nerve fibers come out to the ventral root of spinal nerve as alpha efferents. And these alpha efferents are alpha motor nerve fibers. These innervate the skeletal muscle. So alpha efferents or alpha motor nerve fibers innervate the skeletal muscle. The second neurons in the ventral horn or anterior gray columns are the gamma motor neurons. These are small and multipolar. Their nerve fibers come out through the ventral root of spinal nerve. As gamma efferents. And gamma efferents supply the intrafusal fibers in the muscle spindles. So gamma efferents supply the intrafusal fibers in the muscle spindle. Muscle spindles are receptors in the muscle, in the skeletal muscle, right? And these muscle spindles contain intrafusal fibers, and these intrafusal fibers are innervated by the gamma efferent, So this was about the motor neurons, or in the neurons in the ventral horn or anterior gray column. Now we come to the neurons in the posterior gray column or posterior horn. Neurons in the posterior gray column or the posterior horn. Now 4 groups of neurons are present in the posterior gray column. 4 groups of neurons. The first group is substantia gelatinosa. These neurons are present at the apex of the posterior gray column. Right? And these receive nerve fibers carrying impulses of pain, temperature, and touch. So first group is substantia gelatinosa. These neurons are present at the apex of the posterior gray column, and these receive nerve fibers carrying impulses of pain, temperature, and touch. The second group of neurons is nucleus proprius. Now this group of neurons is present just anterior to the substantia gelatinosa. So just anterior to the gelatinosa group are the neurons of the nucleus proprius. Now these neurons receive nerve fibers carrying impulses about tactile discrimination, or you say 2-point tactile discrimination, vibration, and proprioception. So neurons in the nucleus proprius receive nerve fibers carrying impulses of 2-point tactile discrimination, proprioception, and vibration. The third group of neurons is the Clark's column. Clark's column, C-L-A-R-K-E', Clark's column, or nucleus dorsalis. Clark's column or nucleus dorsalis. This group is present at the base of the posterior gray column. Posterior gray column. These receive impulses from proprioceptors. Keep in mind, proprioceptors are the receptors present in tissues around joints. Which respond to position and movement. These are the proprioceptors, and from the proprioceptors, impulses go to the Clark's column or nucleus dorsalis. Keep in mind, Clark's column is present in the segments from T1 to L to L3. So this group is present in segments from T1 to L to L3. The fourth group of neurons present in the posterior gray column is visceral afferent nucleus. Visceral afferent nucleus is present lateral to the Clark's column, present lateral to the Clark's column, and it receives impulses from the receptors in the viscera. It receives impulses from the receptors in the viscera. This is the visceral afferent nucleus receiving impulses from the receptors in the viscera. So this group is also present in the segments from T1 to L2, L3. So present in the segments from T1 to L2, L3. So these are the four groups of neurons present in the posterior gray column, that is substantia gelatinosa, nucleus proprius, Clark's column or nucleus dorsalis, and then the visceral afferent nucleus. Now the nerve cells present in the lateral gray column. In the lateral gray column. Lateral gray column is present in the segments T1 to L2. The lateral horn is present in the segments from T1 to L2. And this lateral horn or lateral gray column, it contains sympathetic preganglionic neurons. So this lateral horn or lateral gray column contains in the segment T1 to L2, it contains the sympathetic preganglionic neurons. And nerve fibers come out from these segments, which are called preganglionic sympathetic neurons. So nerve fibers come out from these segments, which are called preganglionic sympathetic neurons. Now similarly, lateral gray column is also present in the sacral segments. So lateral gray column is also present in the sacral segments S2, 3, 4. S2, 3, 4. And these neurons are preganglionic parasympathetic. So in the sacral segments S2, 3, 4, the neurons are parasympathetic preganglionic, and these neurons give rise to nerve fibers which are preganglionic parasympathetic. These nerve fibers are preganglionic parasympathetic. So this was about the nerve cells in the lateral gray column or lateral horn of the spinal cord. Now keep in mind that gray matter of spinal cord is also divided into 9 laminae. You see? Laminae 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. Right? So, gray matter of spinal cord is also divided into 9 laminae starting from 1 to 9. And we discuss these laminae when we discuss about the ascending or sensory tracts. So when we discuss the ascending or sensory tracts, then we discuss these laminae of gray matter in the spinal cord. Right? So this was about the physiological anatomy of the spinal cord, and then about the nerve cells in the gray matter of the spinal cord. Right? Thank you.